Okay, we're back, and now I'm going to add on to the last lesson about vector component addition. I'm going to go on and just use the information that we found in the last video. So I'm going back up and using these two particular vectors from polar coordinates. This is the first one. It was the vector of 21. This was our 41-degree angle. And then if you'll remember from the last unit, or the last lesson, 4.1 standard, that the second vector starts at the end of the first one. And so if I did that, this would kind of be a new thing here, and it would go just like this one did. It would go, just realized you couldn't see what I was drawing. It would go down here, just like this vector did. So it went a distance of 32, and this little angle right here is that 13-degree angle in a west-south direction. And so the resultant vector is from the start, which was at the origin, up until the end of that second vector. This has an x and a y coordinate. We realize that this x coordinate is negative x and then a positive y coordinate. So it's basically combining these two vectors to get to this endpoint. And that's what vector component addition is. You take the x and the y rectangular coordinates, and so the first one was 15.849 and add, or excuse me, and then 13.777, and we're going to add to that the second coordinate, negative 31.18 and negative 7.198, and get a component for this x and y. So 15.849 minus 31.18, turn it on, gives us negative 15.331. Then I'm going to calculate the y coordinate, 13.777 minus 7.198, and I get 6.579. That's the x and the y coordinate for this endpoint, this being our resultant vector from the start to the end, but the end point was right here. Now this is a rough sketch, and so these coordinates are going to be difficult to tell. That doesn't really look like it went back twice as much as it went up. As a matter of fact, my scale drawing looks like it went up more than it went back. It's a sketch, it's not a scale drawing. What I can tell is it's in the second quadrant. I have a negative x and a positive y. So how can we take this information and go back into a polar coordinate? Because your answers really should be in a polar coordinate as they started in. So let's just picture this spot as an x and a y and drop our perpendicular, which makes this a right triangle. And we want to know, we know the x coordinate, we know the y coordinate, we don't know this length. So using the fact that we have an x, we have a y, how can we find that? That's a right triangle. It's a Pythagorean theorem problem. So we can take our x squared plus our y squared in order to solve for the resultant squared. So in this case, negative 15.331 squared plus 6.579 squared equals our r squared. I'm going to ignore the fact that that's negative because when I square it, it's going to be positive anyways. And I'm going to enter the square root because I know to get my r, I'm going to have to take a square root anyways. So I'm going to enter 15.331 6.331 squared plus 6.579 squared equals, because I've already done the square root, and I got 16.683. What did I just find? I found this distance. This distance is the magnitude of the resultant. So my polar coordinate solution, a magnitude of 16.68. Now, real quick caveat here, that was in miles, that was in nothing. They have to be the same unit. So to fix that, miles. They are. So my resultant, miles. Easy fix. We need an angle. Well, it's clear to me that I have an angle that's going to have a west-north direction. This also tells me it's west because it's negative. Positive, second direction is north because it's positive instead of negative. Negative would be south. So I already know that I've got a west-north direction. But how am I going to figure out what this angle is from the east-west line up to the resultant? That's another trig problem. I've got y and I've got x, and I'm looking for the angle. Which of those trig relationships has a y and an x in it? The tangent of theta is equal to the y coordinate, 6.579, over the x coordinate, negative 15.331. I'm looking for an angle. It's really inverse tan. So I just type that in. Second tan, 6.579 divided by negative 15.331. I got an angle of negative 23.225. Does that angle make sense? Well, I don't want to use the negative, but it does make sense that it's 23.2 degrees. So, let's just real quick for your notes, make sure you've got the formulas for the entire section of 4.2. To convert to rectangular, x equals the magnitude times the cosine of theta, y equals the magnitude times the sine of theta. Two formulas to convert to rectangular. The other two formulas to convert to polar. The x squared plus y squared, and I put r squared up here. If it makes it easier for you to remember, then you can put m squared. It is the magnitude of the vector. We hesitate to use m, even though I did, because it's definitely associated with slope, and we're not talking anything about slope in this section. And the angle theta that we need to find is tan theta equals y over x. Now, another thing, we call it tan theta, but we are looking for the angle, so don't forget you've got to do the inverse tan in order to find it. You need to remember all of these four formulas. You won't be able to do the standard without having those memorized. I will do another lesson with a little bit more extensive problem. Maybe you already understand it from this lesson, but if not, watch the next video.